Quick recap. In the last session, we discussed about the model diagnostic for logistic regression. How do we find out the model performance? For that, we discussed about a couple of metrics like AIC, Kike information criteria, and confusion matrix. And for this, you don't have to do anything. When you use the model summary, you can get this on AIC. So the lesser the AIC, better the fit. Okay. But with one metrics alone, we cannot decide my model is performing well. Just because my AIC is less, we cannot say, right? So my model is performing, we cannot do this. You need to evaluate with various metrics. In this case, I mentioned 7 or 8, 7 metrics. The next one is the confusion matrix. So what is confusion matrix? It is an error metric. This is the one we use. The confusion matrix is an error matrix. This is the one we use to judge the performance of classification related algorithm. This is the one gives us with the detailed information about the accuracy level, precision rate, and error percentage of the model. Okay. And the next one is ROC. So what is ROC? Receiver operating characteristic curve. We are going to take a look at it. In this case, the area under the curve. So the area under the curve is 1. Any value, if your model value, comes closer to 1, that means your model is really performing well. And there are occasions we'll be using precision and recall curve. So we will take a look at when to use ROC AUC, when to use precision and recall curve. So, the point number 2, 3, 4, and including FN score, these 4 are common for all the classification problem. Hence, if you understand it here thoroughly, all the classification same metrics will be using it. So these are 5, 6, 7. Okay, and these things are related to your binary classification problem. In the case of logistic regression, we'll be using it. Okay, but lift chart and case statistic, any binary classification, we can use this one. Okay, so that kind of situation we can use it. But 2, 3, 4, 2, 3, 4. Okay, this is 5, right? Oh, sorry, your numbering problem 5. So these 2, 3, 4, 5, these two are common to all the classification problem. Hence, I would suggest you to concentrate and understand and even revisit my videos. So we already discussed about the accuracy. What is accuracy? True positive plus true negative. You need to add these two values and divide that by all these values. You will get accuracy. And the true positive rate is sensitivity and true negative rate is specificity. False positive rate is 1 minus specificity. Okay, and pressure. This is the formula that we use it. And we discussed about when to use accuracy and when it is not appropriate. What is recall? What is precision? If someone of you can answer it correctly, then you are on track. At the time of, then you are interview ready. Okay, I can, tell you upfront. That means the moment when I complete the class, complete the course, then I can take your profile directly. So what is accuracy? This is what I explained it. What is recall? We discussed already. So when can we use recall? When can we use precision? Okay. When can we use precision? When can we use precision? When it is not accurate, the accuracy. When it is not, give me an example. The interview they'll start with what is accuracy? Did you use accuracy? What is the accuracy of your model? What is the accuracy of your baseline model? What is the accuracy of your reduced model? And how did you do so how did you do feature selection? Which technique that you used it? And can I use accuracy? Can I rely on accuracy metric? That's all. These are the interview questions. 4 questions. That's all. Okay. What is accuracy? Accuracy is nothing but true positive number of samples predicted correctly over the total number of samples. That is what my accuracy. So true positive plus, if you remember that confusion, true positive plus true negative divided by all the values. That is what your accuracy. When can I use accuracy? When I cannot use accuracy? There are some times the accuracy will be more, but if you look at the predicted positive, you know it will not the model, though the model cannot detect even a single instance of true positive, but still the model accuracy can be more, 90% or 85%. That doesn't mean my model is doing good, especially in the case of imbalanced data set. Remember that imbalanced data set, you cannot rely on, you cannot use accuracy. Okay, it will not give you, you cannot go by the accuracy. And when I can go for precision and recall, when can I use this metrics? When can I use this precision? False positive cost is very high. False positive cost is very high. In that kind of situation, I cannot go for, I cannot go for, I can go for false positive cost is very high. In that case, precision. So we cannot afford, even if I have one of an instance has been misclassified as false positive, we cannot afford. What is the example for this? So spam detection, right? So we want to detect this spam, but what happened? We could see that 5 emails were wrongly detected as, okay, spam detection is not the right thing here. Spam detection false positive, right? So in that case, yeah, so in the case of this one, you know, payment gateway, okay, payment gateway, this one, the security, okay, the thing is transaction, payment gateway transaction. If the transaction is failed, or if the transaction is something like, you know, some anomaly transaction happened, or something fraudulent activity happened, fraudulent transaction. So in that kind of situation, false positive, it says wrongly it is positive. Actually, they did not do anything. But in that case, what you do is you are going to track something unnecessarily, you spend time, right? And in the case of other classic example is false positive is like the cancer, right? Medical false positive means wrongly says the person is having cancer. In that case, he has to, actually it is negative, but it says positive. So in that case, he has to go treatment unnecessarily. It will spoil his health. So in that kind of situations, the false positive cost is very high. That kind of situations, the objective is you need to reduce the false positive cost, right? So for you need to, sorry, you need to reduce the false positive values. You need to reduce the false, you cannot reduce the cost, you need to reduce the false positive values. For example, you have something like 100 people, wrongly my model predicted they have cancer, actually they are non-cancerous, they have to undergo chemotherapy. Okay, so you need to reduce this false positive values. That is the goal here. Customer, this the project at the time of problem statement, so they will tell you. So we want to reduce the false positive. Already some models will be running. Sometimes they'll come back to us and they'll say, hey, we want you to reduce the false positive, right? So that is where you need to focus. That is the objective of the project itself. Okay, and in some cases the false negative should be less. Okay, even if the false positive is very high, let it be there. We are not going to lose anything, and false positive should be, negative should be less. Take the same example, cancer. Okay, though my model wrongly predicted a person is having cancer, he will not die. He will not die. But a person is having actually cancer, but my model wrongly predicted the person is not having cancer, then he will die. This is very critical. So in this case, you cannot afford even one single person. If you have 100 values here, 100 people wrongly misclassified your model as false negative, these people will die. At least if they go for therapy or something, they might survive. Or at the beginning stages of the cancer itself, right? Actually, the beginning stage itself, it found positive, but my model predicted wrongly he doesn't have cancer. 100 people. maybe these 100 people recently, they are at the initial stage of the cancer. So at least in the initial stage itself, if the model correctly predicted they have cancer, then if they go for therapy, they might recover completely from the cancer, right? So this is this is unacceptable. Even if you have one record here, this is unacceptable. Another thing is fraudulent transaction. Actually, a fraudulent transaction happened. A model wrongly predicted is not a fraudulent transaction. That specific transaction happened with a huge volume of huge money, 1 million or 100,000 or 10,000. Sorry, 1 million or 0.5 million, $0.2 million fraudulent transaction happened. My model wrongly predicted. It is negative. It is not fraudulent transaction. Even if you have one record, only one incident has been classified wrongly as false negative, it will have a serious impact on your business, especially in the case of financial institution, right? This is a very serious issue. In US, because of this false positive and false negative, they lost millions of financial institutions. They lost millions and millions of dollars. Okay, so in that case, you need to reduce this value. Supposing you have 100 is there, you reduce it to at least, let's say not 100, let's say you have 52 are there. So if you reduce it to 10 or 5, it is fine, right? The lesser the thing, it is good. Instead of having it, but even one transaction is still a problem. The expectation will be very high, but model cannot be that much accurate, right? So if you can reduce it, it will be great, but in realistic in reality, it is difficult to bring it down to 0 or something, but there are some cases we can do it. But the point here is, in the case of false positive, if you're false positive, cost is high according to you, right? Then you need to use the precision. With the help of these precision metrics, you can evaluate how well your model is doing it. And next one is the recall. If your false negative cost is very high, like I said, fraudulent transaction happened, but my model, in that case, you need to use recall. The whole objective in this case is, in this kind of use case or requirement, business use case is nothing but you just think about the business requirement. Okay, the use cases, we cannot afford even a single instance or record to be classified as false negative, even though it is positive. So in that kind of situation, the objective is reduce the false negative values. Okay, after now let's say you make some changes to your model, you changes the threshold value. Even after that, you are testing it out, and let's say you retrain your model, and then you changing the threshold value. Okay, and then you construct the confusion matrix, and then if you see the values are reduced, it's fine. But still, which metrics that you'll be using it, recall. So even in this case, even if the transaction is non-fraudulent, if my model wrongly predicted as a fraudulent, it is fine. Anyhow, we are not going to take any, even if you take action, the customer will come back and say, no, I'm the one owning this car, nothing, right? So they will tell, end of the day, you are not going to lose the money. But here, you'll be thinking that it is non-fraudulent. Actually, it is a fraudulent. You're losing a money, huge money. If 100 customers, if my model wrongly predict, you're gone. Even for one customer, if my model predict wrong. So in that kind of situation, after you retrain your model, after changing the threshold value, to check this one, you can use recall metrics. This is the one you can use it. This is what we discussed. The next one is the ROC curve. Receiver operating characteristic curve, area under the curve. So in this case, it is a graph. ROC curve is a graph. This is the graph. Okay, it is showing the performance of a classification model at different thresholds. Okay, don't worry about threshold and all. I'll explain you right after this, because if I keep talk theoretically, we will not be able to. First of all, we need to take a look at how to implement the logistic regression model. We will be doing it shortly. So in this case, in the y-axis, true positive rate and false positive rate will be in the x-axis will be plotted. So in the interview, they'll ask you, in the case of ROC AUC curve, So what is the x-axis value? What is the y-axis value? True positive and true negative rate, true, false positive rate and true positive rate. Okay, the area under the curve. So this is the one. If it is closer to 1, okay, the area under the curve value ranges between 0 and 1. Anything which is closer to 1, your model is able to separate both the successful and failure observations, or true or false observation. Your model is able to separate it correctly. So the value is 0 to 1. Okay, the higher the value, it is better. The greater the area under this curve, in simple term, so greater the model's ability to separate the responses, whether it's spam or non-spam. Okay, this is what your ROC curve. This is to view the performance of classification model. And we have true positive rate, false positive rate. So these two we'll pick up from the confusion matrix. And then AUC ranges in values from 0 to 1, as I said. And the model whose predictions are 100% wrong has an AUC. Yeah. So if you get something 0 that is 100% wrong, your model is not at all predicting anything. So fine. Next, what I will do is I will jump into the Python, and we will start train the linear logistic regression model. Logistic regression model is, it falls under the classifier. We call this a classifier. All the classification related algorithms like neural network, decision tree, classification model. But decision tree and all, we can use it for both regression as well as classification problem, except logistic regression and linear regression. And other algorithms can be used for dual purpose, most of the other algorithms.